What's up, everyone? Today we are back with another video from the math industry. Today our new topic is the radical functions, directed by me. Topic 1, simplifying radicals. So perfect squares, the list of perfect squares would be 1, 4, 9, 16, 25, 30, and 36. Perfect cubes would be 1, 8, 27, and 64. Perfect fourths would be 1, 16, and 81. A sample problem would be negative 2 square root of 294m to the power of 16 and times n to the power of 7. So doing this, you have to split up the numbers. So basically give them different categories like square roots. You get negative 2 square root 49 times 6, and then times m 16 over 2 times 7 over 2, which gives you, in the end, when you solve it, it becomes negative 14 square root 6m to the power of 1 over 8, and then times n to the power of 7 over 2. Okay, another problem would be negative 5 cubic root negative 80a to the power of 5. So, to do this, you just do 5x minus 2x cubic root 10x a to the power of, 10 times a to the power of 3 root a to the power of 2. So, solving this problem, just filling in the blanks. These kind of problems are like filling in the blanks. So what you get in the end would be negative 10 cubic root 10 times a to the power of 3 root a squared. Okay, we have topic 2 now. It's operations with radicals. Okay, so the very first problem would be negative square root 6 minus 3 square root 45 plus 2 square root 96. So the second step would be to divide it into categories, basically just split them up, and yeah, so you basically factor out a common factor from this. So it becomes negative square root 6 minus 9 cube root 9 times cube root 6 plus root 16 times root 6. So then after that, it's a easy thing from there on. So you just combine the like terms, which in the end gives you negative 2 root 6. Another problem. How interesting. 2 over 5 plus 3 root 2. So for this question, 2, which is 2 over 5 plus 3 root 2, you just invert the bottom denominator and multiply the numerator and denominator with the new denominator, right? So it just becomes 2 times 5 minus 3 root 2 over 5 plus 3 root times 5 minus 3 root 2. So it's just plain sailing from this. So it's just you multiply both top and bottom, which gives you 10 minus 6 root 2 over 25 minus 18. So after you simplify the question from there, you get 10 minus 6 root 2 over 7. Okay, topic 3. The example is rewriting a fraction into radical form. So basically you move the denominator to the root area and numerator as a square. So for the example problem 16, 1 over 4, that would give you 4 root 16. So basically you move the 4 to the left, and then you put a square root there, and then underneath the square root you have the 16, and then the 1. but since 1 is just 1 itself, you don't have to write the 1 in this problem. Another problem. A to the power of 2 over 3. So that's basically the same thing as the first one. So you just get the cubic root a to the power of 2. Because, like, 3 goes to the left, but that looks like a cube, so it's a cube, you know. And then 4. Solving radical equations. Root 5x minus 1 plus 4 equals 11. So, first things first, you move 4 to the right side and remove the root. So, it looked like 5x minus 1 equals 7 to the power of 2. Then after that, 7 to the power of 2, you solve 7 to the power of 2, so it's 49. So 5x minus 1 equals 49. Then you move the 1 to the right side, so it becomes 5x equals 50. Then when you do when you solve it, so 50 divided by 5, then x equals 10. Right? Easy. Another question. Root 3n minus 27 equals root 43 minus 2n. So, since both of them have roots, you cancel out the root, which gives you 5n equals 70. And then you get n equals 14. Okay, topic 5 now. It's called graphing radical functions. So you guys know what a square root looks like, right? So basically it just looks like from 0 or any other number on the x line, it basically rises up really steeply, but then over time it just like gradually starts to recede. Then after that, cube roots on the graph, it looked like a S shape, and it's very interesting. So for this example problem, f of x equals -2 cube root x minus 1. Basically, the first thing you do is create like a table. So x would be -8, -1, 0, 1, and 8. Then y would be 2, -1, 0, 1, and 2. Then you fill out the other ones on the right side, as you can see here, as the result from the x and y. And then the domain and the range would definitely be all real numbers because they're extending to both sides. You can tell from the table that the graph will be a cubic root function on the graph, and the end behavior would be as x approaches infinity, f of x approaches negative infinity, and as x approaches negative infinity, f of x approaches infinity. The increasing intervals are any number. Increasing interval would be nothing, and because it's not increasing, it's technically not increasing, it's decreasing on the graph. And decreasing intervals would be negative infinity and positive infinity. Another one. F of x equals negative cube root x minus 4 plus 3. So I didn't show the table here on this one, but as you can see from the first example, that's what you should do. So the domain would be all real numbers, and the range would be all real numbers as well. The point of inflection would be 4 and 3, and the end behavior for this would be as x approaches infinity, f of x approaches negative infinity. As x approaches negative infinity, f of x approaches infinity. The increasing intervals would be NA, and the decreasing intervals would be negative infinity to positive infinity, so any number. And then after that, what it would look like on the graph would also be a cubic function because it has an S shape. And okay, that's good. You're doing a great job listening. Yes. Last topic. It's topic 6. Inverse functions. So, first problem would be f of x equals 2 over 5x minus 1. So the first thing you do for this is to replace the f of x with a y, so it becomes y equals 2 over 5x minus 1. Then after that you get x equals 2 over 5y minus 1, because you like replace the x with the y, switch it around, do the old switcheroo thing. Then you do 2 over 5y minus 1 equals x, so you replace the negative 1 with an x. Then it becomes 2y minus 5 equals 5x, so you move the 5 to the right, and 2y equals 5x plus 5. Then that becomes y equals 5 over 2x plus 5 over 2. Then you get f to the power of negative 1 x of x equals 5 over 2x plus 5 over 2. For problem 53, f of x equals root x plus 3. So for this, you do the same thing on the top, the first problem. So you replace the f of x with the y, so it's y equals root x plus 3. Then you do x equals root y plus 3. Then root y plus 3 equals x. Then root y equals x minus 3. And then y equals x squared minus 6x plus 9. Then finally you get the answer f to the power of negative 1 of x equals x squared minus 6x plus 9. That will be the end of this video. I hope y'all learned something, and please subscribe and like to this channel.